Hi there. Welcome to Infoblox Automation with Postman, Part 5. My name is Glenn Gray. I'm an enterprise architect with over 20 years IT experience. Today, I'm going to demonstrate how using REST APIs and Postman can make managing DNS, DHCP, and IP address management a lot easier. In this episode, I will demonstrate how to design a systematic method for creating and applying validation standards to resource objects and their specific key value pairs or property fields and values at rapid scale. I will also show how to parse invalid objects and correct them in order to bring them into validation compliance standards. Let's get started. Okay, I'm going to start out with Postman already open, and I'm going to point out some changes compared to the previous episodes. First of all, I've changed my workspace name from the Scratchpad default, and I've given it a name, local.lab. In addition, I've renamed my collection, and I've skimmed down some of the items that I have in the collection. I'm just wanting to work with these particular resources within Infoblox just to make it simpler. I am going to be covering records again, which, if you recall, we had focused on things like record type A and record type quad A here and here. Also, I have added some environment variables. So as I go to the environment, my variable set, which I labeled Infoblox, I look at, and there's more items here than we had previously looked at. If you recall, the variables that are stored within my environment help me reuse things such as the URL definition, username, password, so forth. Now, I've also added, as I scroll down, schema definitions. Now, these definitions are JSON objects that I use to validate the responses that come back from the Infoblox database. I'll describe this in more detail in just a moment. I'm just showing you the placeholders. Notice that they're all post-pended with the underscore schema, and I'm doing that by design. Now, as I go back to my collection, if you recall, the test scripts where I had applied them were at the root folder. Now, they don't have to be at the root folder. I can apply tests at subfolders, in which case they override the tests that would be applied at the parent folder. Just going to close that. This happens to be the only one that I'm applying a test to a subordinate folder, but otherwise all of these, for example, as I look at records, I'm not doing any tests here. So it would inherit the tests that are applied at the parent folder, which is the root Infoblox API. Now, as I look at tests, we're going to see more tests than what I had originally applied. In the original scenarios, or the scenarios from the previous episodes, I was basically applying these test scenarios and portions of this bottom one, which I've enhanced a bit more. I'm going to cover what I've done and the reason why. So the very first one was just to get the JSON payload, and that's determining if it were defining in the query return as object, which I could specify a fixed number of objects that I wanted returned, or if I did not use that, it would by default return a maximum of 1,000. So the point of that was to consistently return just the JSON data, regardless of whether or not I had returned it as an object or not. So the second item was where I applied the visualize HTML code, which converted the JSON response into a readable HTML spreadsheet format. Now, this new section here, which I've added, does basic tests, like tests the response code, and it's saying that Postman function is going to expect the response code to be one of 200 or 201 OK. Sorry, 200 or 201. 200 OK responses would be the ones I would expect in a get, a put, a delete. A 201 would be an expected response in the case of a post. I'm also validating or testing the response times for each response. And in this case, I'm setting a maximum value of 500 milliseconds. So response time is less than 500 milliseconds. Expect response time to be below 500. Now down in this section, I've added a few things. I was doing an if-else in the previous episode, but it was really only determining if the request was not a get and else the request is a get. Now what I'm doing here is I'm storing the response in a collection variable. Now a collection variable, which we hadn't covered before, is going to be assembled here. Right now it's blank because I have nothing pre-populated, and they will be populated as I run a query with each of these sets. And you can see I have a few scattered throughout as I highlight that. Now in this case, I'm just taking the response from a non-get request and storing the response into a variable which I've called object reference, because as you do a delete, a put, a post, that is all that is returned is a underscore reference to the record which you've either deleted, updated with a put, or created with a post. If it is a get, I am returning the object definitions or data from the Infoblox system. So in that case, I'm going to want to store some items. And the very first thing that I'm identifying here is a variable which I'm calling underscore all refs. And I am first putting a list structure together, but the very first row in this list is going to be the resource definition postpended with the underscore all refs. And I'm doing the same to create a list called passing refs, failing refs, sub obj refs, and sub rec refs. Each one of those is going to be dynamically named because I'm creating a variable called underscore resource, which represents the request URL path and popping the very first item in the path. So to describe what that is, I'm going to show not all records, I'm going to show the a record get request, which I've named list record :a. The URL variable, which I get from my environment variable, you'll see the scope environment and the variable definition that we have here. So in that, it's populated into the request line itself. The very first item which I'm popping is the resource definition. And then after the question mark, you have your query parameters, which I can enable and disable here. And you'll see that the address bar expands as I select and deselect them. I'm also defining which fields I want returned for each record, and I'm introducing an additional query parameter, which is saying, hey, I want only the objects with a creator key field and value of static. So I'm going to go ahead and run this, and I see I get my responses back with, since I've selected return as object, I have an object, which contains a result, which is an array of the objects, this being the very first object. And then I have multiple objects afterwards. Now, the rest of my test script, which let me point out really quickly that the variables, since I had a set definition in there, have now been stored. Since I ran that, it stored in the all refs a list of all of the reference key field and values. Now going back to my test, I created each of those lists, and as I proceeded down, I got into the for loop, which reads through the JSON data, which if you recall is an array of each one of the objects. So as I iterate through the JSON data list, I'm setting the variable object, and then I'm going to store the property underscore ref as a variable and push that into the all refs list. I'm also setting a collection variable to that particular object reference, which, since I'm going through a for loop, is only going to retain the last value, but don't worry about that for right now. The test, which I'm going to be performing, is a validation of each object. So as I'm iterating through the list, I'm looking and testing each value with a function. So the very first one, which I use a try, catch, throw structure, is first going to test and expect the JSON objects that I'm iterating over to have a JSON schema matching the schema. Now, the schema I had set from the environment variables. So the environment variable I'm getting is going to be the resource schema definition. So let me go back to my environment variable set, and since I have a long list, I'm going to query just for the one of interest, which is record:"A, and I have a schema here. So this schema, which I've already copied and pasted over to a notepad so it's easier to view, contains the definition of what each object in the database should contain or should not contain. Now what it's testing here in this definition is it is of type object and has properties ref, comment, creation type, creator, DNS name, extension attributes, IPv4 address, name, TTL, use TTL, view, zone. Now, how is this definition actually testing things? Well, first of all, I'm doing things like testing DNS name and its property names to have a pattern. In this case, it's a regex pattern expression that says, hey, the object has to end in .local.lab. In addition, I'm testing things like the extension attributes to make sure it is of type object with properties. First of all, services, which is a type object, which has properties, and a value that is of type string and at least one character in it. And I need there to be a value in the services object property. Likewise, work order must be of type object with properties and value and property names matching the pattern regex must begin with hashtag, is of type string, has a minimum length of at least one character and a maximum length of 8. So in this case, it's got to have a hashtag to start with, and 7 digits at most following. And for that property, I'm requiring it to have a value. Of the object extension attributes, I'm requiring both properties, work order and services. As I go down to TTL, the only TTL values that I want every object to have should be one of the enumerated values, and its type must be number, and it should be either 1600, 3600, 86,400. And finally, all of the responses and objects must contain the properties _ref, comment, creation time, creator, and so forth. So this constitutes the definition I'm expecting every object in the record A JSON data table to contain. So as I go back over, that was pasted into here as my object schema definition. So just to point it out again, these are the properties and these are the values. So key field and value. And I'm testing things like the work order has a value, is of type string, starts with a hashtag, property TTL is of type number and is either 1600, 3600, or 86,400. And likewise, the DNS name must end with .local.lab. So as I go back over here, that is what this section here does. It expects every object to have that JSON schema. If not, it stores it in the failing refs. If it did, it stores it in the passing refs. So at this point, I've collected all refs, those that pass, and those that fail, and I've parsed them. So as I go over to my variables, I can see all of these refs passed that test. All of these refs failed that test. And this is the collection of all of them together. Now, there's nothing in the record A subobject ref and subrec refs because those lists apply to other resources and their structure. But right now I'm just demonstrating the record A structure. So as I go back over to my response, which ones actually failed and why can also be shown here in test results. Notice that 17 of 23. So I have 23 total A records right now in the system, and it has shown me, well, the very first test, if you recall, I did an assertion to test code, is it 200 or 200 OK? And all of them passed, I'm sorry, not all of them. Since I only issued one request, which was list record A, that response came back 200 OK. The response time was less than 500 milliseconds. In this case, it came back at 80 milliseconds. Now, the first item failed. Well, why did it fail? It's saying the expected data to satisfy the schema, but found the following error. Data.extension attributes should have required property services. So let's take a look at from the body. I have extension attributes, but I only have owner and work order. And if you recall, I required that work order and services be in the response. So that is why this one failed. Let's look at another. Here, this one's different. Well, it also does not have services, but it also does not have work order. And the data TTL should be equal to one of the allowed values. So let's take a look at the 1, 2, 3, 4th item in the response body. There's 1, there's 2, there's 3, and there's 4. There's no extension attributes. And the TTL value is 60, not one of the accepted parameters. So how can I correct these all very quickly? Well, I can first of all take the failing references, and the references again are the hyperlinks to each record object. So looking at the response, these references are hyperlink pointers to each one of these objects. And in order to change each of the objects, this is the required hyperlink that I needed to store so that I can now iterate through them and quickly modify them. So I'm going to go to my failing references. I'm going to capture them all, highlight and copy, and go over to my collection set. I'm not going to do a post on these. I'm going to do a put on these so that I can update them. Now, as I look at my post definition, you can see that I have the variable in that is going to be pulled from the collection variable set. And it's referring to the record :A underscore failing refs. And I'm going to be changing these items to the prescribed or defined TTL value and other values that I have stored in my variable object list, which back over here to the variables, getting rid of that, it would be the acceptable TTL value here and the other variable definitions which I have. So in order to update the failed records, what I will need to do is iterate over those items, which if I go to the put folder, I can perform a run. And this was demonstrated in the previous episode with put. Now, as I run these, I will want to select the file. Now, I've created a blank file here, which I called record A failing refs, just a blank. File, and that's where I'm going to paste those particular CSV organized references that I had been calling and storing from the test. So as I iterated over the list, I stored each one of the references, and I put at the very first row the name, the dynamic name of the resource, and then post-pended it with my schema, or not schema, my naming mechanism. So as I call these in this run sequence, it's going to match it with the put request. So record :A underscore failing refs, and then we'll go down this list. Oops, let me just show this really quickly again. The request item is going to refer to that, which is the very first row in the CSV file, which matches this name. And the runner, which I have selected that file, and I actually didn't select it. Did I save? There we go, let's save. Now we're going to pull that in. And I see I have my preview of each of the 6 records that did fail. do this again because it's not showing the number of iterations as I expect. So as I go back to my put folder, select run, select the file, I copy and pasted the failing refs, which were stored in the collection variable. And open the file. Now I see that there are 6 iterations or 6 rows in that file, and I can go ahead and run. And you'll see that it quickly goes through. I have pass, 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 all the way down, 200 OK. I've completed the 6 iterations, 2 seconds, each taking an average of 33 milliseconds. Now when I go back to the list of A records, I can send the query again, and voila, all of my objects now pass my data schema, and I have updated them all dynamically. I'll do one more iteration on quad A records. I'm going to close that run. Now we have 20 total objects in the database. They're all displayed here. I only want these fields. I've specified return as object. Again, that's optional. And I'm specifying that each of the objects returned match the criteria of creator must be static, so that I'm not getting the system generated objects, only the objects that have been created by request. Now, I'm going to cover really quickly, how did I create the JSON schema definition? Since I've already populated them, I want to show you how I created it. So, copying one record item, I'm going to take this over to a notepad. First I'm going to paste it, select it all, and then structure the format properly so that I take out the unnecessary tabs and white spaces that came since it is indented several times, but I need to remove those indentations. So putting it there, I can take this and use a JavaScript package to quickly generate a JSON schema. Now I do this with a Linux platform. You can use Windows, but I just prefer to use the Linux platform. And I've loaded node.js into this Linux platform, which you can also get for Windows and install and use in MS-DOS command prompt. What I'm going to do is create a file, and I'm going to just call it RESP-JSON to represent a JSON response. And I'm pasting a particular object, doesn't matter which one, any object that typifies a acceptable passing JSON response body. Now, in this case, I don't have the TTL value, so actually I don't want to use that one. I'm going to go back to the response. I'm going to scroll down. Let's see if I can quickly find one. Yeah, it's going to be, let's just go to the last one. So as I hit Control End here, I know that the last one is good. So I'm going to take the last one as my sample use case, copy it, go back over to a blank notepad, take out the indentations, copy it, back over to my Linux platform. Whoops. get rid of all of these, paste it, and save the response.json. So you'll see my file here, resp.json. Now there's a package that I've imported with npm called json-schema-generator. This is going to generate out of the response JSON, which I captured as a sample, and then create a schema JSON definition, which is the -o, the output file. So as I do that, it's created with node.js, and this is the definition. Now there's a few things in here that aren't implied or inherent, and that would be the specific property definitions that I walked through to begin with. So for example, in the TTL, it's just saying, oh yeah, I recognize that the TTL contained a value and it was of type number, but that's all that it can infer. It can't infer the acceptable values because it would have no idea what the acceptable values are. And so as I go back to where I had modified and started with things like, yes, the TTL, which is of type number, must be enumerated with one of these acceptable values, and the property under work order value must have property names with pattern matching a regex expression, a minimum length of 1, maximum length of 8, which going back to the schema output raw did not contain. So these are additional definition parameters that you'll want to assert so that your schema definition evaluation is completely accurate. You can see that the work order originally came with, yeah, I'm looking for it as a string, must be at least one value, length, one character, but I had additional definitions, and that's where I applied those statements. Well, the minimum length is 1, but the maximum length is 8, and I want to apply a property match, a property pattern evaluation using a regex expression, like so. Now, once that has been defined, I copy and paste the entire the entire JSON schema definition into the environment variables, which I had already placeholders. So this time I'm doing quad A records, and here in the quad A record schema is where I have pasted the finalized schema definition, which again I'm doing property name evaluation on the DNS name. It has to end in .local.lab. Same thing with the work order, pattern match, same thing with the TTL value. So not much different than what I was doing with the A record, slight variation because I only have 2 enumerated values in this definition. But as I performed that evaluation, only 7 of them contained matching or passing, and the other remaining ones did not, and we can see why they were failing, each one. So as I go back to the root folder of my collection, I look in my variables, and magically I have now the dynamically created CSV arrays for each of the variables that were stored. So I have all the references, I have the passing references, I have the failing references. So again, I'm going to take this, copy it, go back over to, I'm just going to use the same file. Doesn't matter what it's named, even though it's named record_A and not quad A. I'll just highlight all values, paste it. This is dynamically correct, applied to the name of the put URL string, not post, but put, and we're at update record quad A. You see that I have the record quad A underscore failing refs and the definitions that I'm wanting to update. So in this case, I'm going to apply an additional comment. I want to have all of them with the desired extensive attributes and the correct TTL value, and maybe in some of them the use TTL was not true or activated, may have been false by definition, so I'm going to go ahead and apply that too. So now I can click on the put parent folder, select run. Before I do that, I want to go back over to the file because I didn't save it. I see a little red banner there. I'm going to save. Still not showing. Let's just do this. It is a CSV type. There we go. And we'll replace it. So now that I have my file saved, I should be able to select the file. There's 13 incorrect records within my database, so I will run it. And it iterates through each one of them. Average of 33 milliseconds, 13 iterations, 4 seconds. Run my get again, and I fixed all of the incorrect ones. So that is a quick overview of how to apply schema level validation to every object within a particular resource type. I hope you've enjoyed it. Very powerful, very quick.